In this video, I'm going to show you three properties you can use to kind of combine multiple logarithms. These are properties that we're just going to touch on and you just get a basic sense of how they work. They can be confusing. It doesn't seem like they would be after you've seen an example or two, but it's very easy to mix up when you can and when you can't use them. The first property involves when you add two logs together. So what I did here is I wrote the three properties in black, and in blue I tried to write the everyday English of it. When you add two logs together that have the same base, so here they're both base 10, all you're going to do is you can combine them into one log and multiply the insides together. When you add logs, you multiply the insides. When you subtract logs, you divide the insides. So if you have log A minus log B, it's log whatever A divided by B is. And our third property here is by far the most important of the three for our purposes in this class. So I'm going to put a star by this and write down that it's important because this is going to be the key that lets us solve equations, and we'll see that in the next video. If you have the log and you're taking the log of something with an exponent, so it's a to the b power that we're taking the log of here, we are allowed to take that exponent and basically drag it down out front of the problem. So if there was a b in the exponent here on the inside, we move it out front. It's the same thing as b times log of a. That is going to be a big deal in our next video. In this video, though, all I'm going to do is really show you guys how you can use these log properties to make things look a little simpler. So for my first problem here, I have log 5 plus log 3. When I add logs, I multiply the insides. So if I do that, I will get log 15. And what I did here, just to show you guys that I'm not lying to you, I did log 5 plus log 3 in the calculator there. Just typed it in separately, and I got a decimal, which shouldn't be surprising. You can get a decimal for a log. And then I did log of 15, and you see that the decimal is exactly the same. So you are, in fact, allowed to do this property here, just to give you guys some proof. On our second problem, I can't type these in the calculator because there are variables in there, but if I add the logs, I multiply the insides. And when I multiply x to the third times x to the fifth, I get x to the 8th power. When they're side by side, you add those exponents. And actually, this is nice because it allows us to use another property we have here. There's an exponent on the inside here. I can drag that exponent out front. So I end up getting 8 times log x for my super finalized answer. My third problem here, I'm subtracting the logs, so I'm just going to divide the insides. 40 divided by 8 is 5. So this is the same thing as log 5, and I could show you in the calculator again real fast. I might as well. If I do log 40 minus log 8, log 40 minus log 8, I end up getting this decimal right here. And if I do log 5, you can see that it is in fact a matching decimal. For my last problem here, when I subtract the logs, I divide the insides. X to the 6th over x squared is x to the 4th. So I get log x to the 4th. And I can even go one step further, dragging that exponent down out front and make it 4 times log x. So little properties we can use to make things look easier or simpler. In the next video, we'll really see why these properties are so important.